Hi, this is Ayman. In this tutorial or in this demo, I'm gonna show you how to use some of the DevOps automation stuff. Mainly, it is the first step in DevOps automation, which is the infrastructure as a code. In production, it should be followed up by other steps, which is configuration management tools using either Ansible or any cloud native tool, followed up by CI/CD pipeline, which is responsible for committing in a repository, building artifacts, making some tests, unit tests, and linting testing, and followed by deploying the application code on the existing infrastructure that are being built and configured using the infrastructure as a code and the configuration management tools. And that, last but not least, should be have some automating testing, such as performance testing, load testing, smoke testing, whatever the testing type that we will use. But that the whole pipeline of DevOps automation. But what we will focus here is the infrastructure as a code by building infrastructure on Microsoft Azure. So what we will do mainly are three kinds of building or automation. First of all, we are going to create Azure policies. Azure policies could be done either on the subscription level, the resource group level, or even the resource, which is restrict some actions to be done by the users. So what we will do in our policy is we will restrict users to make tags on the resources. Following by that, we are going to make Packer images using HashiCorp Packer tool, which is responsible for building images on multi-cloud providers, either Azure, HashiCorp in general, our generic company, could be used to build Packer images or provisioning infrastructure using Terraform on multi-cloud provider, Azure, GCP, AWS, or even VMware. So what we will do is building our virtual machine image, is an Ubuntu image, and then we will configure the image to act as a web server by just echoing some comment in the index.html file. And then we will open port 80 also on the operating system level. Also, we are going to open port 80 also at the cloud level, but at the operating system level we have to open port 80. And last but not least, using Terraform, we are going to provision our infrastructure. So our infrastructure will be 3 Azure virtual machine. Mainly, we will deploy 3 Azure virtual machine, but in your environment variable file, you can configure whatever the number of the virtual machine you need. And then we will deploy a load balancer that is responsible for load balancing the traffic across the virtual machines. And of course, we'll make network security groups, network interfaces, OS disks, as we will see later on. Okay, first of all, this is a repository which has the code. Let's clone it. And then let's cd into this repository. Here's our code. We have 3 main directories, which is the policies, Packer, and Terraform. Let's try to tree this. Yes, here it is. We have the makefile. Makefile is one of the best tool that can be used in automation, which has sections, and each section can run bunch of commands. Also, there can be sections calling other sections, as we will see. And then we have, maybe let's focus on the policies. This is the first thing we'll make. We'll make policy definitions, which will creating our policy. And then we will make assignment. Our assignment could be on the subscription level, on the resource group level, whatever. What we will do, we will make a policy. that restricts each resource should have a tag on it, and it will apply on the subscription level. And then we will build our package image. We have two files here. The first one, we will make just a resource group called whatever the resource group. That the resource group will have the resources that will be deployed by Packer, and then the image will be taken, and then these resources will be deleted automatically. And server.json is the code that will automate the provisioning of the Packer image. And then our Terraform is going to provision our infrastructure, which will be our load balancers, availability sets, virtual machine, virtual network interface, etc. So let's begin with the makefile. Let's get our makefile. So the first section in the makefile is preparing your environment. You have to prepare your environment well. You have to set your environment variables to what we will. So what we will do here is, let's try to open another window. Yes, okay. So preparing your environment is going to give an execution privilege to this script, which is set the env, and then we will run the script using the bash shell. Let's try to cat these scripts. So what this script do is simply it export our environment variable into our local shell, and our environment variable is in a file called .env. Unfortunately, I will not be able to cat this file since it have my credentials, my subscription ID, my client ID, my client secret, but I have an example of IAM file. Let's show it. Mainly that file, you can modify it and rename it into .env. So that's the environment variables that you have to modify. First of all, your Azure subscription ID, your tenant ID, client ID, secret ID, the location you need to deploy your infrastructure in. In my case, I am deploying my infrastructure in East US. The resource group of the Packer image, my Packer group. The image name will be my Packer image. The OS type will be Linux Ubuntu. The publisher will be Canonical, and the SKU of the operating system. Build resource group is the name of the resource group of the Packer image. The VM size, you feel free to change this to the size you need, and the public and private keys, as well as your SSH fingerprint. And here is the same environment variables. I just add the prefix of the tf_var in order for Terraform can understand these environment variables, and the VM size, and also the image name, the full part of the image name. You have to add the subscription ID here and your package image. Also the host name will be host name, and you have to add your username and password, and that's the most important part, which is the total number of your virtual machines. I choose here 3 virtual machines, but feel free to change this to whatever you need. So that is for our set environment. That's the most important part. It's set our environment variable as well, and then we are going to run our so you are going to give the execution privilege into these scripts as well. You will see them later on. The next section is tagging policy definition. What we will do is to cd into our policies, and then run that script and going back from the directory. Let's see the script. Policies. It is tagging policy definition execution. What that script is do is that I'm going to simple Azure command that is going to create our policy definition. So that's add definition and create our tagging policy. Sorry. With the name tagging policy, and the most important part is the parameters of the policy and the rules that will be done. These are the two files which exist in the policies directory. Let's get tagging policies, tagging policy definition params. The parameters is the tag should have the web server -env tag, and the rule is to make sure that this tag exists, otherwise it will deny the creation of the resource. And for the assignment also, it is the same concept, which is assigning the policies that we have done into the subscription level. So also a simple easy command which had the parameters of the Azure assignment params. Following by that, the tagging policy. That's the cool thing in the makefile, which you can call other sections in the specific section. So you have the tagging policy calling the tagging policy definition and the tagging policy assignment. So simply you can just run make tagging policy, which will run the previous two sections, and then the packer RG, which is going to create our packer resource group that we're going to provision our infrastructure, which will be deleted later on, but also it will provision our image in this resource group. So let's also get that. Also an Azure command that's going to create a resource group with the environment variable we have been set, the location, and the tags, which is the web server equal to production. The next is we're going to build our packer template, which is in server.json. So that we are declaring our environment variables from the variables in the packer file from our environment variables, and when declaring our variables in the builder section from our variables. And the provisioner section, we are just making an image which will be configured as below. We're just going to echo hello world into the index.html file, and we're going to open port 8080. So you are going to open port 80. Also, this packer build is going to build these two commands. And last but not least, for Terraform, the first important command, which is Terraform init. As we have said, Terraform is a generic tool that is used to provision infrastructure on multi public or private cloud providers. So what we're going to provide here is to provision the infrastructure of Microsoft Azure. So we have to install the plugin of Microsoft Azure, and feel free just to run this command, which is Terraform init. And Terraform is smart enough to detect the plugin that is has to be installed from your code. The next steps is Terraform plan. Terraform plan is going to see the differentiation between your code and your infrastructure on cloud, and is going to say a report which is will be outed into the solution.plan. The report will investigate or will show what is the changes that will happen from your existing infrastructure on cloud and from your re-provisioning infrastructure. So it will not provision. Terraform plan is not provisioning infrastructure, it's just showing what will occur. And then Terraform apply, which is going to provision the infrastructure, but the -- auto approve flag is for automation. So if you just run Terraform apply, you have to type yes to confirm, because Terraform apply is going to run Terraform plan behind the scene, and you have to approve that. So that's why we add the -- auto approve flag to avoid stopness of the code. And then Terraform build is just a section which is run all of these three sections. And last but not least, Automate is going to run all of these stuff by preparing the infrastructure, tagging policy, Packer build, and Terraform build. So we can just run make automate, which will build everything on the cloud. But we will do it step by step. So that is an introduction of what we will do. We can also take a look of Terraform and what will be provisioned. But mainly before Terraform, I just need to... Okay, so yeah, I just stopped the recording and come back after copying my .env file, which has my credential of subscription ID, client ID, and etc. So I will not be able to cat this file since it has my credential. For security reasons, I will not show it, but as I said, you can just modify the example.env and rename it into .env. Okay, so let's now take a look on Terraform. First of all, our vars file are just files that has our variables, and we are not setting our variables from here. We are just setting into our environment variables by using the tf_vars prefix. But just we modify that to make the default number of virtual machines into 2. So if you do not set your number of virtual machines in your environment variables, it will be by default 2 virtual machines. What is the most important file? I think solution.plan is from my last build, so now you should have no solution.plan. Also, I think I have to remove it from my repository. Okay, what's going on? Okay. The most important file is main.tf. Take a look on it. Okay, what Terraform will do? First of all, it will build our resource group, which is called it rg-web servers, and then it will build our virtual network, and it will make our VLAN, or sorry, it's not our VLAN, it's our subnet in this virtual network. So our main virtual network is with prefix 16, and we make subnetting by taking 255 addresses of it and make it specific for the web servers. Here we are creating 3 public IP addresses for our virtual machines. Mainly this is the way we are for looping in Terraform. We are just initializing the count with a number of virtual machines and call it, and what will Terraform? It will going to loop 3 times on this resource, followed by creating our network interfaces, creating our network security group. Here I am opening all the traffic between the virtual machines. Mainly this is not the most secure way to make that. You have to limit the traffic. And then I am deploying I am just associating the network interfaces into the network security group. Here we are creating our load balancer. We are creating the back end of the load balancers. We are associating the 3 network interfaces to our load balancer. We are making availability sets for high availability, and last but not least, we are creating our virtual machine from our Packer image with the host name, username, and password in our environment variable. Okay, that's in brief what will Terraform do. So let's go into the most interest part, which is beginning with creating our policies, images, and infrastructure. So just we will call our make file but we will call every single command in a separate way. So we will just make our preparing environment. I need just to make sure that my environment is set correctly. Unfortunately, as I said, I will not be able to call the env command since it will show my credentials. The next step is making our policies. So what we will do, we will just make tagging policy, and what we have done here is that he is creating the definition and then he is assigning the policy. So if we go here in Microsoft Azure and go into our policies, we will go into the definitions, and if we go searching for our policy by typing tag, we will see our tagging policy here. And as we see, we should see one assignment. Yes, here it is, the tagging policy assignment has been created successfully. Okay, so the next step we will do is to continue on following up the sections in the make file by provisioning our Packer images. We can simply make this command to create our resource group, or and then make this command to create our Packer image, or simply you can make the Packer build and it will create the resource group of the Packer as well as the Packer image. The resource group is now has been created. Here it is, and then we will begin with the building our Packer image. So if we just refresh that in order to see our resource group, we should be able to see our resource group. What Packer is doing now is making a deployment and provisioning our resources. Here is our resource group, my Packer group, and if we go to our deployment, we see one deployment has been deploying. Here is our deployment. We should see that a virtual network has been created, a public IP address, a network interface, and the virtual machine is still created. We could refresh that. As you see, the location is in East US, as we set it in the environment variable. What Packer will do now, it will begin. If we go to the resource group for an overview, we should see the resources. Yes, here is the resources have been created: a virtual network, a virtual machine, a disk, a network interface, and a public IP address. What Packer will do now, after finishing these deployment, I think now he is deploying the virtual machine and the OS disk, is the most resources that takes time. What Packer will do after he finish, it will going to take a snapshot or an image from the virtual machine as well as the disk attached to it, the OS disk attached to it, and after that is going to remove all of the resources. So what Packer is doing now is taking still deploying. Now it's not still deploying. What Packer will do after deployment is going to SSH on the virtual machine and begin with taking the snapshot. Could refresh that. It's still creating. Also, Packer will give us the here it is, the public IP address of the virtual machine. Now the virtual machine is creating successfully. Packer is SSH. Also, Packer is configuring our virtual machine with the configuration set, which is echoing the hello world and opening port 80. And then Packer is going to SSH, connected SSH now. If we go here and ping on this virtual machine, should ping, but maybe we are a little bit late since the virtual machine has been the snapshot has been created and the virtual machine is powered off, as you see. So now we should see the resources is deleted. Now we should see first of all the the packer image has been created, and then the resources will be destroyed. It's still creating our snapshot. Here's our packer image. It has been created successfully. And what will packer do now is going to destroy all of the resources that is used to create the virtual machine, and then the image has been created. We will see the logs still taking the snapshot. Okay, in order to save time, I think the image has been created successfully. We can go through Terraform and go back into Packer to see if the resources has been deleted. Here it is, the resource code has not been created. He is deleting individual resources. As you see, the virtual machines has been deleted, the network interfaces, the public IPs. So if we refresh that, we should see the resources has been deleted. Okay, anyway, let's go to Terraform and go back to Packer after the resources has been created, but keep in mind that we cannot run Terraform unless the Packer image has been created, because Terraform will call the Packer image and will build our virtual machine from that image. So what we will do now, we can go into the makefile and simply we can run the Terraform build, which is going to run the Terraform init, Terraform plan, and Terraform apply. Just simply run. Let's make sure that these resources has been deleting. Yes, here it is. The OS disk still exists, but it will be deleted later on. As you see, Packer has finished in 4 minutes and 39 seconds, and we should see only the Packer image now. Okay, we will run Terraform build to build our infrastructure. So first of all is initializing our plugins, installing plugins of the Azure RM. That's the plugin used to provision infrastructure on Microsoft Azure Cloud. And as you see, can you see our plugin in the Terraform directory? Then keep in mind that code is running in the Terraform directory. Plugins is still installing. The plugin is installed in a directory called .terraform, and we will see it now. As we will see, the OS should be deleted. Still exists. It should be deleted since Packer is no longer needs this OS. Since and as you see, the Terraform init has been run successful, and as you see here, we will see our .terraform directory, which has our providers will be Microsoft Azure, Microsoft Azure RM, and here we see our Terraform plan has been run successfully. If we take a look at the first of the plan should be executed and have the output in the solution.out, but also the output is here. We have the Azure availability set has been created successfully, the load balancer of the web servers. It's not been created, it's what the change will occur. The load balancer back and address pool, the 3 virtual network interfaces, the association of the network interfaces to the load balancers, network security group, and no, that's the association of the network interfaces to our network security group, which is 3. And here it is, our network security group. The rules of the network security group, which is the 2 rules, the inbound and the outbound rule. The public IP addresses, which are 3 public IP addresses. The resource group, maybe that's one of the, it should be the first one that will be created. The subnet that will be created, and last but not least, the 3 virtual machine that's gonna be created. Keep in mind, if we see here, we should see that the virtual machine image is the Packer image. Here is a tag that we should assign in order for the virtual machine to be able to be created. I don't know where the part which says that the virtual machine is created from the Packer image. But anyway, here's 3 virtual machines that should be created and the virtual network. And in that part, Terraform plan has been finished. It says that we are going to deploy 25 resource, and now that Terraform apply is creating the resources, as we see, creating the load balancer. The most part that will take time is the virtual machine. Yes, here it is. The virtual machine is still creating, but if we go, let's refresh that and make sure that the OS disk has been removed. Don't know why it still exists. If we go to our resource groups and make a refresh, we should see our production resources group has been created, and here is our resources that has been created: our availability set, load balancer, virtual network, network security groups, the load balancer public IP address, and the 3 public IP addresses of the virtual machines, the 3 network interfaces, the 3 virtual machines, and the 3 OS disks. And as we see, our Terraform has been executed successfully, and these are resources. By curling the public IP addresses, we should load balancing on the 3 virtual network interfaces. I just make sure that this result has been deleted. Why it still exists? It should be deleted. And that's it. That's the only way. That's the way to deploy infrastructure as a code on Microsoft Azure, using Azure policies, using AZ commands, using Packer images, and using Terraform or infrastructure as a code. Thank you a lot.